Hey there! So we know quite a lot about data factory. We can create various pipelines, but actually how do we execute them? How do we make sure that our batch processing, which is supposed to be executed at every night, can be executed? How can we test that our pipelines actually work correctly before we publish them, before we deploy them to production? Well, that's the topic for today. So let's get started. All right. So the topic for today is executing ADF pipelines. How to make sure that our beautiful pipelines can be executed. Executing ADF pipelines. And as always, we've got different options here. And the first split is like this, that we can either debug them, those ADF pipelines. So debug is the first option, or we can trigger them. Trigger. All right, but what's the difference? And when should we use debug and when we should use trigger mode? And to explain this, we've got to talk a bit about how Data Factory works. How do we interact with it? So let's say that we deployed our wonderful Data Factory service in a cloud. So this is ADF that has been deployed in a cloud in Azure, right? Like so. And then we as developers, we want to interact with it. We want to create datasets, pipelines. We want to implement our logic. And the way we interact with ADF is via a browser. So let's say this is a web browser. And we have a developer who is simply connecting to Data Factory through the browser, like so. And then via the browser, the developer makes some changes, like the developer adds new pipelines or he modifies them. And that's how it works. We use web browser as our interface. And now, before we deploy our changes, those new pipelines that we created, usually we would like to test them locally. We would like to run them to make sure that they run correctly. And that's what the debug mode is used for. So this is the debug mode. And simply, when we debug our pipeline, it means that we are executing the version of the pipeline, of the code, that we see in the web browser, that was loaded to our web browser. So that's what debugging means. And actually, I can show you this in Azure Portal. So I'm in Azure Portal in Data Factory. Let's create some new pipeline, some dummy one, and let's add a simple wait activity that basically waits for 10 seconds or so, nothing fancy. And right now, I'm interacting via the web browser. I'm creating new logic in my pipeline. And if I would like to verify that it works, I would use this debug option, which will execute my pipeline, the one that is loaded to the UI. And then I will be able to see if it does whatever I want it to do. And now, please be aware that even though this is a debug run, the code is actually being executed. So if you copy some data in your pipeline, and if you debug it, well, then the data will be copied. The same if you remove some data in your pipeline and you debug it, well, then your data will be removed. So it is a normal execution of the pipeline, but the version of it that is available in your web browser. All right, so let's say that we are happy with the changes we did, and we would like to deploy them to our Data Factory service. So it would be later scheduled to run on a, let's say, daily basis. And now this deployment process, it depends on a configuration of our Data Factory, because simply Data Factory can work in two modes, either with Git integration or without it. And let me show you when this Git integration can be configured. So again, I'm in a Data Factory. So the first place we can see is right here at the bottom, that we don't have code repository set up, which is a clear indication that Git integration is not enabled. The same if we go into Manage tab, and there we've got this Git configuration blade, which says that, hey, Git repository is not configured. So that's the clear indication that in my case, this Git configuration is not enabled. So what does it mean? Well, simply, if you want to deploy the changes that we did in a web browser, you would have to publish them. So there is this publish button available in a in Data Factory, which simply means I want to save my changes that I did, which basically means I want to deploy them. Deploy. And you can see this button right here at the bottom, this publish all. And Data Factory was smart enough to detect that there was a one change made that would have to be deployed. And this one change, if I click on it, it is this new pipeline that we've just created. And when we are working without Git integration mode, that's the only way to persist our changes. So let's say that I close my browser, or simply I refresh its content, like so. Yes, let's just refresh it. And then what happened is that my pipeline that I've just created, but not saved, this pipeline is gone, as if it never existed. It was not deployed, so basically my work is lost. And that's how this mode without Git integration works. So there is no Git integration mode. So that's one thing. The only way to persist our changes is to publish them, which means to deploy them to the Data Factory service. So again, let's create again some pipeline, and let me show you another thing related to this no Git integration mode. So I will just drag a simple copy in data activity, but I will not configure it. So I didn't set source and sync settings, which simply means that right now this copy activity will not be executed because it's not configured properly. And if I would like to publish my pipeline in this state, well, I've got the error because the validation was unsuccessful, which again means that to be able to publish, to deploy our changes in this mode, our code has to be successfully validated, which means that every setting that is required has to be set. And again, think about a scenario. Let's say you've been working all day, you've been creating various pipelines, and then you want to go home, but not to lose your changes. You would like to publish them, you would like to deploy them. But you can't do this if you didn't set all the required properties. And maybe it's too early for you to configure this. So in such case, preserving your work for tomorrow might be difficult. So that's one of the disadvantages of the no Git integration mode, that to be able to deploy stuff, it has to be valid. Also, as you can imagine, collaboration between various developers is quite limited and difficult, simply because every developer, when connects to the browser, like so, every developer sees its own version of the pipelines of the data factory. So the changes that were made by one person, but that were not yet published, are not seen by the other developers. So the only way to share the code and to work as a team on some various features is to deploy them to Data Factory. But again, those changes might not be ready yet to be deployed, which is pretty bad. Then we don't have versioned code in this mode. We don't have pull requests. We don't have automated CI/CD pipelines. So basically, this no-git integration mode is not recommended. All right, but let's say that we finally somehow deployed our changes to the data factory, and that's where trigger mode comes into the play. So trigger. When we use the trigger mode to execute our pipelines, it will execute the code that is deployed to data factory. So that's the difference between debug and trigger mode. Debug, it will execute the code that is loaded to your UI, and trigger, it will execute the code that is deployed to data factory instance. So that's the key difference. And now, because I was talking about this no-git integration mode, let me quickly introduce the second mode that is recommended one, which is with Git integration. So if we use with Git integration mode, the situation changes a lot. So again, we would have a data factory deployed in a cloud, and apart from that, we would have a code repository set up. Let's say we've got Git. So the icon is something like this. So we've got code repository. For example, you might use Azure DevOps. And then you would still interact with Data Factory using a browser. So developers would simply connect to it using a browser. And then when they make some change, like they would add a pipeline, what will happen under the hood would be that every change, it will be stored as a separate commit in a code repository. Which means that collaboration between various developers is much simpler, because if all of them work on the same branch from the same repository, they would instantly see the changes made by the other person. So the collaboration is very simple. Then the second advantage is that actually you can commit the code to the repository that is not working, that is not valid. So it is completely fine to push the code that is only halfway done, and then tomorrow you will continue working on this stuff. In case of no Git integration mode, you are not able to publish such not finished code. And then, because we have a code repository, we've got all the benefits of using it, like versioning the code, pull requests, code reviews, and automatic CI/CD pipelines that we can implement to deploy the stuff, our pipelines, our datasets to the Data Factory service in a way we want. And in future episodes, I will tell you how we can implement those CI/CD pipelines in a proper way, so the interaction with Data Factory is pretty simple. But that's for the future. Anyway, in both of those cases, either with Git or without the Git integration, the difference is the same. Trigger, it executes the code that is deployed to the service, and the debug, it executes the code that is loaded to the UI. So that's the main difference. All right, so as you can guess, the debug mode, well, it should be used basically for local tests. For local tests made by developers. So let's say there is a developer who is implementing some pipeline, and then before this person says, all right, this code is ready to be deployed, he wants to test whether it works. And that's where this debug mode comes in handy. The second important thing about this mode is that it is to be executed manually only. We cannot schedule debug mode to be executed, let's say, every night at 1 AM. No, it has to be done manually by using this debug option. Now, and I would like to show you that actually this trigger mode, it executes the code deployed to the data factory service, while debug mode, it executes the code that is loaded to the UI. So I've got this pipeline free created that has not been yet deployed, and I would like to test it whether it works. To be able to do this, I used the debug mode and it worked. And you should remember that I used the debug mode when I was talking about error handling in Data Factory. Alright, so the debug mode succeeded, everything works fine. And now if I would like to trigger this pipeline, I would use this add trigger option, add trigger now, to execute it now on demand. And let's see what happens. The pipeline is not found, right? That's true. Data Factory is not able to execute this pipeline because we haven't published it. So it doesn't exist in the Data Factory service. It hasn't been deployed, which is a clear indication that in case of trigger mode, it really runs the code that has been deployed. All right, so that's the debug mode. So let's move on to trigger options. And here we've got various possibilities. So the first one you already saw, which is trigger now. And it simply means please execute the version of the code that has been deployed to the service right now, on demand. So it is on demand execution. And like in the case of debug mode, it is run manually. Like so. So let's test how it works. So first, to be able to trigger my pipeline, let me publish it. So let me deploy it to the Data Factory service. It should finish within a few seconds. And then when I would like to execute it, but the code that has been deployed without my changes, if there were any, I will use this add trigger now option, which executes the code that has been deployed. And it should succeed in just a few seconds. And now in the monitoring tab here, we can see all the runs either from the pipeline, either from the debug mode or from the trigger mode. So here you can switch between triggered or debug runs. And you can see that the trigger mode that we just executed, it succeeded. And similarly, we can see some debug runs that we executed a few minutes ago. All right, that's great. So we have this trigger now option, but it still requires someone to go to this UI and execute it on demand. So obviously it will not work when we would like to schedule the pipeline to be executed on a daily basis, let's say at 1 a.m. every night. So how to achieve that scenario? And to do this, we will create a dedicated trigger. And we've got 4 types of triggers. The first one that I want to talk about is called a schedule trigger. Schedule trigger. All right, and how does it work? So again, I'm in Azure portal. Let's add a new trigger. So right now I don't want to trigger it now on demand. No, I want to create a trigger that will fire the pipeline according to the configuration that we'll just define. Now let me create a new trigger because I don't have any yet. Let's call it schedule trigger 1. And here I've got to define what type of the trigger I want to use. And in this case, I want to start with the simplest one, which is a schedule trigger. And this type of trigger is simply a wall clock schedule when we can define when we want this trigger to be executed. Like every day, like so. Let's say every day at 1 a.m. like so. So right now, this trigger, once we deploy it, it will fire our pipeline every day at 1 a.m. As simple as that. So that makes our batch processing possible. We can also use some more frequent intervals, like every 2 hours, if that's what we need. We can specify that actually we want to execute our pipeline on every Monday and Thursday at 1 a.m. Or maybe we want to execute it on the first day of every month. It's up to us to decide what's the schedule that works in our case. So let's start with a very simple schedule, like every day at 1 a.m. And let's create the trigger. Let's publish it. All right, so right now this trigger will be deployed. We can see those triggers in a Manage tab under Triggers option. And here, yes, we can see that our schedule trigger 1 has been created and it is enabled. So it will be executed according to the schedule we just defined. Now, if we take a look at the code, you will see that actually this trigger is associated with a single pipeline right now, but it is an array in the code, which is a clear indication that actually we could use the same trigger to fire multiple pipelines. And yes, this is true. So let me show you how it works. So let's quickly create a new pipeline, pipeline 4, with some dummy wait activity. And here I would like to configure it in a way that it will be executed by the same schedule trigger pipeline. And yes, let's just select it from the list, like so. And let me deploy the stuff, which means in this mode, when I'm not working in Git integration mode, just publish all changes that I made. And right now, if I take a look at the triggers, at our schedule trigger 1, you can see that this time there are 2 pipelines associated with this single trigger. There is more. Let's say that you would like to execute our pipeline 3, not only on an every day at 1 a.m., but also on the first day of every month. Can we do this? Sure. So let's create a new schedule. Let's call it schedule trigger 2, let's configure in a way that it will be executed every month on the first day of the month, let's say at, I don't know, 4 AM or whatever hour works for us. And yes, let's deploy it and let's publish it. And take a look that right now our pipeline has 2 triggers defined. So it is a many-to-many relation between triggers and schedule pipelines. So actually, let's write all of this stuff. So a schedule trigger is simply a wall clock schedule. Wall clock schedule. When we define when or how often we want our trigger to be executed. Secondly, it is many-to-many relationship, which simply means that we can configure it in this way. So let's say we've got 2 different triggers, trigger 1 and trigger 2, and let's say we've got 2 different pipelines, pipeline 1 and pipeline 2. And we could configure it like this, that the first trigger, it is used to start both of our pipelines. And apart from that, let's say we want the pipeline 1 to be also triggered by our trigger 2, the one that is executed on the first day of every month. So basically it is many-to-many relation. And this schedule type of the trigger, it seems simple, but it is very powerful and it is very commonly used. Let's imagine this batch processing scenario when we want our pipeline to be executed every day at midnight. Well, that's the perfect case for this schedule trigger. Alright, so this was the scheduled trigger type. We've got 3 more. So the second one is called tumbling window. Tumbling window trigger. And now please remember this tumbling window name, because it will be used in case of streaming. That's the commonly used term. And how does it work? So basically, in case of tumbling window, we split the whole timeline into equal parts, into equal intervals. Let's say we split it into every hour by hour. So on the size of this interval, let's say this is 1 hour. And we would like to execute our pipeline every hour. And that's where the tumbling window is useful. So how does it work? Well, obviously we define the frequency. In this case, it is 1 window. And actually, let me start creating this. So let's use pipeline 4, for example, and let's create a new trigger. But this time we want to use a tumbling window trigger. Alright, so let's make sure that I use the tumbling window type. And you can see this recurrence option, this how frequently we want this trigger to be executed. And we've got minute, hour, or months options. And now for simplicity, I will set it to run every 5 minutes, which in real life case, maybe it's too frequent, but I want to show you how it works. Now, under advanced options, we have some additional properties we can set to this trigger. So the first option is something called delay. So what is this? So let's say we configured our trigger to fire every hour. Great, because maybe we have a data source that is producing some data, maybe in a database, adding some rows, and every hour we would like to grab the changes that were made during the previous hour and then process it using a data factory pipeline. That's great. That's where tumbling window schedule might be useful. But maybe we also know that actually there is always a very small delay for the source system to save the data in our source database. So we want to wait for a very small time, few minutes maybe, before we start our processing. So that's the delay. That's the part that we can configure, and this is it. So basically, we tell data factory, dear data factory, I want to execute my pipeline every hour, but please wait for 5 minutes or 2 minutes or so before you start executing it. Because we know that our data source, it needs those few additional minutes to persist the data we want to read. So actually it means that our trigger and our pipeline will execute at this moment after this delay. So that's how it works. Then what is important that in every window, so this 1 hour, this is our processing window, we have access to some additional values like window start. Oh, actually, let's use this period. So let's say that the pipeline executed here after this delay. So in this execution, we'll have access to additional parameters like window start and window end dates, right? That indicate what was the previous window that has just finished, that caused our pipeline to be executed after this small delay. And now please note that this delay value, it doesn't impact those start and end values. If we configure it to run at 1 AM exactly every hour, then start will be 1 AM, end will be 2 AM, and it will not be changed because of this delay, those parameters. But obviously the actual start time of the pipeline, it will take this delay into consideration. All right, so let's see how we can use those additional properties, those start and end values. But before we go there, let's talk about some additional features of this tumbling trigger type. So we've got something called max concurrency. So what is this setting? So basically, what is unique to a tumbling window is that we can use it to backfill our data, which means that we can schedule it or configure it to run for the past, for the data that was created in the past. In the case of schedule trigger, the first one, it can be only configured to run in the future from now. For tumbling window, we can go to the past. So let's say that we have a data in the source that we would like to process, but this data is already stored there, and we would like to reuse the same logic that we'll use to process the future data. In the case of tumbling window, it's perfectly fine because we could set the start time of our trigger to the past, and it will simply start processing those windows one by one up until now, and then it will proceed with regular processing. And now, to make this backfilling process faster, we can define this max concurrency option, which will tell how many instances of this trigger can be executed at the same time. So let's say we set it to 24. It means that at the same time, 24 instances of our trigger can be executed. And in the case of backfilling scenario, it means that if we set it to some past date, then it will immediately trigger 24 triggers each for its own window. So the first one would be from midnight to 1 a.m., the second one from 1 a.m. to 2 a.m., the third one from 2 a.m. to 3 a.m., and so on. So it will allow us to very quickly backfill data from the past. So that's a nice thing we have available in Tumbling windows that doesn't exist in the schedule ones. So we've got these concurrency options available. What is next unique to this trigger type is this retry policies. So take a look that here, in case of Tumbling window trigger, we can simply set please retry this trigger, retry the pipeline if it fails. You should remember that when we were talking about error handling, I showed you how we can do this at the activity level, that many of them have this retry policy available. But here, in the case of Tumbling window, we can set it at the scope of the whole pipeline. If it fails, just retry it, if that makes sense in case of our use case. And again, this retry policy at the trigger, at the pipeline level, is not available in the schedule trigger, only here for the Tumbling window one. So let's write it down that we've got those retry options. All right, so actually, let's create this trigger. But before we do this, let me show you how you can make use of those window start and window end parameters. How can we pass them from the trigger to our pipeline? So later on, we could use them, for example, to query our database and ask for only the data that was created within our window. So I will cancel creation of this trigger, and let's add two new parameters to our pipeline. So let it be window start and window end, like so. And then in our trigger definition, let's create a new trigger. So Tumbling window trigger. Let's make sure to select a proper one. Let's set the recurrence to every 5 minutes, so I will be able to show you how it works. And that's it. The rest of the stuff, let's leave it as default. So please create it. And it detected the trigger that actually our pipeline has those two parameters expected. So we should set them somehow. And now, different types of triggers, they expose this special data that is available only when we use them. So for example, in the case of Tumbling window trigger, we've got those 4 special variables we can use. And the ones that we are interested in right now are these two: window start time and window end time, which tell us, well, what was the window for which this trigger was executed. In case of schedule trigger, we also have access to some variables, but only to those two. So let me copy this value and let me use it here. Now, there is no this nice builder expression available here, so we've got to just paste the actual value for the window start and window end, and we'll see whether this will work. All right, so let's publish this. And in a second, in the worst case, within 5 minutes, this trigger will be executed, and then we'll see that actually those window start and window end parameters, they were properly populated to the size of our window. So this is how it works. And we will monitor execution of this tumbling window trigger here under monitor. We can also see it from the trigger point of view, right here. And here we've got different types of triggers available. So right now we covered the schedule one that wasn't yet executed according to the schedule because we set it to run, I believe, at 1 AM every day. And the tumbling window will be available here just in few minutes. So let's wait for a second and I will be back once some data is available here. All right, and I'm back. The trigger has been executed. We can see it here under tumbling window triggers that indeed it was executed. And we can see in the properties that we have those variables available with like window start time and window end time. And if we take a look at our pipelines, then this one, pipeline 4, it was executed by our tumbling window. And here we can see what parameters were passed to it. And we can see that yes, our window start and window end were set properly from the trigger. So later on in the pipeline, we could use those parameters to query our data source and, for example, grab only the data that was created within this window part. And then, because we might configure the delay, the execution of the pipeline will be postponed by a few minutes, but those window start and window end parameters will not be affected by this delay property. All right, so that's how this tumbling window trigger works. So if you compare the schedule one to the tumbling window trigger, the difference are quite obvious. And one more thing that I didn't talk about yet is that in case of tumbling window, it's a one-to-one relationship. So you have to create a dedicated tumbling window schedule for every pipeline that you want to schedule in this way. So if you want to backfill your data, then the only way to do this is to use a tumbling window trigger, because the schedule one is not able to execute for the periods from the past. And then the tumbling window, it has these retry capabilities that are not possible in case of a schedule one. Likewise, the concurrency settings, we have them in the tumbling window case, not for the schedule one. Also, depending on a trigger type, we have access to various system variables. In case of a tumbling window one, we have more of them compared to the schedule one. And the final difference is this relationship between triggers and pipelines. So analyze those differences and choose the trigger that works the best in your case. All right, but those both trigger types, schedule and tumbling window, well, they were executed according to some upfront schedule. Let's say once an hour or every night. That's great. But what if we would like to have a more dynamic execution when we want to execute our pipeline when something happens? Is it possible? Yeah, it is. So we've got two additional trigger types that fall into this event-driven category. So the first one that I want to talk about is a storage event type. So storage event. And it simply works like this. We can register our trigger, our pipeline, to be executed whenever some blob is created or deleted on a data lake. Which means that it allows us to respond without any delay. as soon as, let's say, user uploads a file to a storage account, we can execute our pipeline that would pick this file and process it. So here we've got an event-driven architecture. And under the hood, if you are curious, it uses something called event grid. Event grid. And I will talk about it in a second, but let's first configure this trigger type. So let's move on to our data factory. Let's create a new pipeline and let's simply add a wait activity. So obviously it doesn't do anything. And let's say that we would like to execute this pipeline whenever some new file is uploaded to our storage account. And to make use of this, or to get access to the uploaded file, our pipeline obviously would have to know what was uploaded and where. So I will for now create a single parameter called file name that will store the name of our pipeline, of our file that has been uploaded. And let's add a new trigger. This time it will be a storage event type. So file uploaded trigger. And take a note that we have to indicate what storage account we want to monitor. So let me choose our source data or table data lake demo. I think that was the one that we used in the past. Yep, that's the one. Then we've got to indicate which container we want to monitor. And in our table data lake demo, we've got this row container. And in the past, we used it to just dump data from a Azure SQL database. And we'll reuse the same container. So we want it to be a row container. Oh, actually it is like this. Now I can additionally filter the files that I want to monitor. So not all files, because it would result in triggering the pipeline way too often. So I can define in which directory the files should trigger the pipeline or how they should end. I mean the file names. So let's say I want to end my files like something.csv. So only they trigger the pipeline if there is a CSV file uploaded to the row container. And then I've got to register to a proper event. In our case, it is blob created. I want to ignore empty blobs, so I don't want to trigger the pipeline if it is an empty file. And that's it. So let me create this trigger. And here, because the pipeline expects this file name parameter, let's see what kind of variables are available in case of this storage event trigger type. And we've got 3 of them, like file name, folder path, and start time. And the one I want to use right now is this file name. That should store the name of the file that was detected. So like this. All right. And let me publish it. All right, so the trigger and the pipeline is being published. And in the meantime, let me talk about this event grid stuff and more about event-driven processing. So what happens is that we have something called an event producer. So event producer, which in general might be whatever we want. In our case, it is simply a storage account. Which fires various events whenever something happens, like when the file is created. It fires this event saying, hey, new file has been created, and maybe someone is interested in this information because someone would like to do something as a response. Then we've got this middle layer, this event grid stuff, to which this event is sent, like so. And then on the other hand, we've got various event consumers. That register to the event grid to listen for some event types. And in our case, the consumer is data factory that registered for file created event on a specific storage account. So whenever new file is created or modified on this storage account of the CSV type in this raw container, then ADF should respond and fire our trigger that in turn will execute our pipeline. So let's see if that works. So I'm in a raw container and I will upload some CSV file. So I've got file 1 that I would like to upload, and this file right here, it should trigger the pipeline. Why? Because it was uploaded to a raw container on our storage account and it has the matching extension. So if we take a look at triggers and the pipelines, so first of all, let's take a look at the triggers at the storage event ones. And yes, you can see that it has been fired, the trigger. And if you take a look at the pipeline, so that's the one that was just executed. It was triggered by our file upload trigger. And in the parameters, yes, we got the name of the file that triggered the pipeline. We could also add this file folder parameter that would clearly indicate where this file was uploaded. Likewise, if we go there to the file and if we modify it like so, it will also trigger the processing. See? We've got the second execution of our pipeline. So you can see that it is instant. This event processing, it doesn't have any delay. Basically, it's a real-time response. Something happened, and immediately we responded with running our pipeline. So if our requirements say that whenever some file is uploaded with some data, we've got to process it without any delay, then those storage event triggers might be very useful. Just be aware how you set the configuration of this trigger to not fire it on every file that is uploaded to the storage account, because most likely there will be some other files uploaded there that you don't want to execute the pipeline. All right, great. But the problem with this storage event trigger type is that it is able to process only events from the storage account. But what if we have some application that does some heavy lifting? It has some calculations, and once those calculations are finished, we would like to execute our pipeline. Can we do this? Yes, we can. Obviously, we cannot use this storage event trigger type, but there is one more option that we could use. It is simply a custom event type, like so. So again, it uses this event grid infrastructure, but this time it is up to us to make sure that the event producer, which might be some source system, it fires this specific event, and then that we subscribe our data factory to this particular event. So it requires a little bit more configuration, then the storage event trigger type. And let me quickly show you how it looks like. Oops, not trigger now. New trigger. So let's create a new trigger of this custom event type. And you can see that actually we've got those various stuff related to event grid. So we've got to configure it a little bit in a more advanced way than in case of the storage event type, because in the latter case, in the storage event case, it was done automatically by Data Factory. Here, because it is a custom event that we will create, it is up to us to configure it in a proper way. But this functionality exists, so it is a way to have this event-driven processing as a response to some event that is generated by us. All right, so let's summarize everything that we've just discussed. So you should remember that we've got various options to execute our pipelines. We've got, first of all, split into debug mode and trigger mode. And for debug, you execute simply the code that is loaded to the UI. That is useful when you want to test your pipelines before you publish them. And we've got also the trigger mode that allows us to execute our pipelines without supervision in an unattended way. So we can use a schedule trigger to run our pipelines, let's say every night at midnight. We have this tumbling window schedule that allows us to split the whole timeline into equal intervals, non-overlapping ones, and then execute our pipeline every, let's say, hour. And then we've got those two event-driven triggers, one that responds to events on a storage account, and finally the one that allows us to customize the event that is generated. So that's it. I hope it was useful. Thanks for watching and see you next time. Take care.